Moment, though, I want to ask you a question. How do you deal with this? When you're presented with a mass spectrum of a molecule, how do you turn the data into a molecular formula? That's easy for you guys to do. And there's the answer, right? Now, when it comes to a real mass spec, if you were to go into the organic lab, synthesize a molecule, and use the instrument that I have in the back room, get the mass spectrum for that compound, the instrument will not tell you, here's the molecular ion, right? The instrument's not capable of doing that. You have to do that on your own. You have to figure it out, which one's most likely the molecular ion. But oh boy, did we make it easy for you when you get to test questions, homework questions, and quiz questions. We usually put the number in parentheses, circle it, or write MI right above it. So when you look at a problem about mass spec, you will be told what the molecular ion is. In this case, it's 72. All right? So if the question is, what molecular formula might correspond to this molecular ion of 72, the easiest way to go about it is actually right there. It's called the rule of 13 because you want to divide the molecular ion number by 13. And if you do that real fast, what do you get? Isn't that 5.876? Making that up, of course. I don't know what the points are. So you do the division, you get 5. 5 must be the number of carbons that the molecule contains. What else is present? Well, 5 really would account for, 5 carbons really accounts for how much of the molecular mass then? What's 5 times 12? Come on, guys. It's only Monday. 60, thank you. And the balance then is 72 minus 60 is 12. So what's the molecular formula of this molecule? C5H12. Maybe. But C5H12. Now, I have a warning up here. Always test the molecular formula. Actually, it's got an exclamation point at the end of it, right? So it's always test the molecular formula. Maybe that's not quite right. Always test the molecular formula. Right? However you want to say it with the proper emphasis. All right, now we're waking up. All right, a little bit. So how do you test that? How do you test C5H12 as a legitimate molecular formula? CnH2n, anything else? Plus 2, right? So compare C5H12 against CnH2n and check to see if it's legitimate. So n's 5, 2n's 10, plus 2 is 12. Huh. Now what's that really tell you, that formula? That formula corresponded to an alkane, correct? The CnH2n plus 2 formula. That corresponded to the formulas that would be alkanes, correct? So what it really is a maximum value. So if we had calculated C5H10 as the molecular formula that would have corresponded with the molecular ion, then that would be a legitimate formula too because it's less than CnH2n plus 2. That predicts 12 is the maximum number of carbons that could be on 5. Sorry. That predicts 12 is the maximum number of hydrogens that could be on 5 carbons. So any number less than 12 would have been right. Or possible, I should say. But if it exceeded 12, that would not be possible. Had we calculated C5H14, you'd have to say, no, that's not possible. Okay? Make sense? All right, good. So C5H12 is a possible molecular formula for this compound. Are there any others? Well, if we knew that this was just a hydrocarbon, we'd be done. But there's nothing up here that says it's just a hydrocarbon. What if it were an alcohol? Now we got to take C5H12 and squeeze oxygen into it. What do we have to remove from C5H12 in order to allow an oxygen? What's oxygen weigh? 16. How many carbons and hydrogens add up to 16? 1 carbon and 4 hydrogens. So if I take C5H12, deduct 1 carbon and 4 hydrogens, that gives C4H8, correct? Now I can add in an oxygen. So C4H8O is also a legitimate formula for 72. See how that works? Okay? And you can play that game almost endlessly. No, eventually you run out of options, right? What if there were 2 oxygens? Well, then you'd have to subtract another CH4. Now we're getting down to only 3 carbons. And then the question becomes, is that a real molecule still? All right, so there are other issues. But I wanted to go through that exercise once with you so that you realize how you can take a molecular ion number, and if you know something else about the molecule, then you could say, hey, here's the molecular formula that goes along with this spectrum. Okay? Questions or comments or anything? Need to say anything?